Welcome to Easy Elimu Learning Simplified. My name is Eric. I'll be taking you through this topic, mass, weight, and density. And for this lesson, we're going to cover weight. So we want to see what weight is and how you can find the weight of a given body. So we have a few questions to help us with demonstration on how the weight of a body can be calculated. And at the end of the lesson, we'll have some questions in the form of assignment to help you with practicing on what we are going to cover during this lesson. So, what does it mean when you talk about weight? So, weight of a given body can be described as the measure of pull of gravity. You know, so what is the extent of pull of gravity on an object? You see, so we are talking about pull of gravity on an object. So it is the measure of pull of gravity on an object. How much is the pull of gravity on that object? So the SI unit of weight is the Newton, and the symbol used for Newton is capital M. So we have the formula that is used for calculating weight. You take the mass of the object, you multiply by the gravity of a particular planet or of a particular place. Gravity definitely varies from one place to another. So the weight or weight of an object will depend on these two factors. How much is the mass? So what is the mass of that body? And then what's the gravity of that particular place? So find the weight of each of the following objects on the Earth's surface, given that the Earth's gravity is 10 newtons per kilogram. So weight is given by mass times gravity. So mass is 38 and the Earth's gravity is 10. So this is 380 newtons. See, that is very easy. So there is another one here where we have an object that weighs 1,000 newtons on the Earth's surface. You're supposed to calculate the mass. So what I'll do with this is to draw the formula triangle. So you have W is equals to mass times gravity. So now we want to find mass. So it will be the W up there divided by gravity. So mass should be equal to weight divided by gravity. So weight is 1,000 newtons and gravity is 10. So 0 cancels 0. Then I have 100 what? Kilograms. That is again so easy. So Jane's weight is 556 newtons on the Earth's surface. What is her mass in kilograms? Again, I'll still try to use the formula triangle. So weight is equals to mass times gravity. So now we are trying to find her mass. So it will be weight divided by gravity. So again, mass should be equal to weight over gravity. So what's her weight? 556 newtons divided by gravity, which is 10. So the decimal point will move to the left one step. So this is 55.6. kilograms. That is again very easy. So we have this one here, whereby we are talking about the mass of 7.5 kilograms, has a weight of 30 newtons on a certain planet. Calculate the acceleration due to gravity on this planet. So this basically we are trying to calculate the value for gravity. So still, so I'll still use the formula triangle. So now we have weight. So you have the weight is equals to mass times gravity. So we are looking for gravity now in this case. So gravity should be weight divided by mass. These horizontal lines, they mean division. Vertical lines, they mean multiplication. So G again equals to W divided by M. So what is W? Weight, 30 newtons. And we're dividing by 7.5. So how do you get the answer here? You can multiply both numerator and denominator by 10. So this one by 10, this one by 10. So all the zeros in the numerator will remain. So that is 300, but the 0 down here will be used to remove the decimal point. So that is 75. You can try and divide by 5, both of them. So that is 1, 5, 6, 60. So 5 here 3 times and 5 there 12 times. And so we have 12 divided by 3, which is equals to 4. So on this particular planet, acceleration due to gravity is 4 newtons per kilogram. So that is how you go about it. You, especially when it comes to using the formula triangle, it's very, very important when it comes to remembering what appropriate formula is supposed to be used. So we have a few questions here to help you practice and just to help check on your understanding of the concept as has been discussed in that. Otherwise, this is all for now. Till next time, goodbye.